كذلك كدنا ليوسف ما كان ليأخذ أخاه في دين ملك نشاء ففوق كل ذي قالوا إن يسرق فقد له من قبل فأسرها يوسف في نفسه ولم قال أنتم شر مكانا قالوا يا أيها العزيز إن له شيخا كبيرا فخذ قال معاذ الله متاعنا عندنا إذا لظالمون
Hello guys, how are you all? This is me Totality IO. Don't worry, I am here right now. Um, 1 minute, I'll be here. Okay, I'm gonna be here. I'll just mute my mic. I'm not going anywhere. I just prayed and come back. I was studying since 7 then when I started my live stream, so don't worry. And I'll tell you what all things had happened before that, okay? So I've been here for a long while. What happened exactly was I was streaming today at 3. I was attempting to stream at 3 o'clock. I had so many work things going on. Technically it was 3:20. It's my mistake though, but I actually literally forgot to go live. I thought I was streaming, but I had forgot to go live. That's why it wasn't showing any kind of data. But I don't know why the data, the main important things that I need to note down. But then I don't know all things had happened. This was my mistake. I shouldn't have done that. But yes, I thought I was streaming from 3 o'clock, but no, it wasn't. So it was my mistake. If you don't know what I've been doing the previous time, I was just doing some physics practical work, then a bit of batch work, and also I was doing this physics work. So yeah, I've been doing this work, but don't worry, we'll now continue. Let's complete this and then we'll move on to the other subjects. Around the line integral around a closed path of an imperial loop path in free space is equal to mu naught, that is the permeability of free space, into the net current passing through any surface enclosed by a closed path. So I enclosed. Something you like. Ouch, 1 minute. Wait. Yeah, the nail broke off. My toenail got broken off. I don't know how. The line integral around a closed path is equal to the permeability of free space and of the current
So नहीं हमें फोन दियो को मैं बहुत अच्छी ना
by a
ये तो क्या हमें कुछ या इसकी
by a
कुछ है
closed loop.
आइसक्रीम मैं और एक खाऊं
Like,
और एक आइसक्रीम खाऊं
no good.
मैं
Okay. So the line integral of a magnetic field and the length of the, did I mention that? Oh, I just write it as that. Okay. I mean, wait. Okay, then I'll have to check about that now. Okay. So the line integral of a closed path is equal to the permeability of free space of the current enclosed by a closed path or a closed loop. Actually, it is around a closed path in free space. The line integral of a magnetic field around a closed path in a free space. Okay, so I have to say it nicely. The magnetic field around a closed path in free space is equal to the permeability of free space of the current enclosed by a closed path. Okay. Now, talking about this one, let's say that we have a current, and let's say that I have this kind of coil. let's say this is the one I was thinking about. This is I, and this is the one which is in any direction. Let's say, okay, let's say that this is here, B vector. This is R. Got it? Yep. Then this is DL, right? B vector, by the way. That's how it's gonna go. Now the B vector will be so clockwise. Sorry, anti-clockwise. So the line integral of a closed path in a free space is equal to the permeability of free space of the current enclosed by closed path. The line integral of magnetic field, the line integral of magnetic field around a closed path in a free space is equal to d mu naught into I enclosed, or current enclosed by closed path. Okay. Let me just draw the diagram completely nice. So let's say I have a current carrying conductor here, and I took a amperial loop type of surface which is in this direction, and I traced this B vector, and I showed this. Now this is gonna be BDB vector if I take DL, but okay, no problem. Ouch. So this is R, this is DL. For some reason they're taking some small part of here. Did we do that? Yeah. Then technically, first of all, we need to know that dB is equal to, or actually it's not like this, it's B dl, the integral of this, the whole integral, is equal to, we need to prove that this is mu naught I. Now this is the derivation of the Ampere-Wheel circuit, or Ampere-Wheel circuit law. How are we going to do this? So we do know that B is equal to, oh, we didn't take this, right? Mu naught by 4 pi into I into 2 pi r, or I should take this 2I by r. We're taking the, okay, got it. 2, no, wait. Then there should be pi as well, as far as I remember. Wait, what? What? So mu naught by 4 pi into 2I by r. Okay, that's forming law. Got it. Then if I take the line integral b dl, b dot dl vector, basically this is b dl cos theta, and theta is 0, so cos 0, and that will give us line integral b dl, which is basically b the line integral of dl is equal to, now, mu naught by 4 pi into 2I by r. This is 2 pi r. Now wait. This should be small r, my bad, and this is also small r. Now that's fine. So if I do this calculation, I should get mu naught into 2, no, 4 I pi r by 4 pi r, cancel this pi r and this 4, and we get mu naught I. So b dot b vector dot dl vector, this line integral is basically equal to mu naught I, and based on that equation we get the ampere circuit law. So consider a current carrying conductor where a magnetic field lines radius along the conductor in concentric circles by the Biot law. No, it's not Biot's law, it's something called, I don't remember it. I have to remember the law's name. So let me just check it out. What's the name of the law? Then we can normally do it. So as far as I remember, I have to go here, then here. Okay. Oh, yeah, it's Biot-Savart's law. Biot-Savart's law. My bad. So I should say it nicely. Okay. Oh yeah, I didn't draw the perpendicular signs, right? My bad. This is supposed to be perpendicular. My bad. We don't need to mention here perpendicular. This is theta. Then we have to check this one out. Again, so what is Ampere's circuit law? I'm gonna write this whole thing again. I know this is just for practice purposes. I do this always so that I can improve myself nicely. So the line integral of the magnetic field around a closed path in a free space is equal to the permeability of free space of a current enclosed in a closed path. That's the Ampere circuit law. Hooray, we got it. So let me just write that down. The line integral, let me do that fast. The line integral of magnetic field lines, magnetic field, okay, around a closed path in free space, is equal to the permeability. Actually, it's supposed to be written as it is directly proportional to the current enclosed in a closed path. Uh, but mu naught, which is permeability of free space, is a constant, so we are including that for some here. So for some reason, so is equal to permeability of free space of current enclosed closed path. Easy law. Then so what does it basically say? If I take the line integral of b dot dl vector, the dot product of these, and then their line integral, I'm supposed to get mu naught I enclosed. That's their meaning of this law. So that's what it says. It is according to the things I've studied, it is very much similar to uh, Gaussian's law or Gaussian's theorem or Gauss theorem. So we call it as magnetic equivalent. Yeah. Then talking about the statement, consider a current carrying. Okay, you know what? I always draw diagrams first, then the statement, because that gives me a much more idea than the normal things I usually do. Like what I mean by that is sometimes whenever I try to okay, 1 minute. What is this? Consider. Oh my god, bro. What is this, bro? Consider a. Yeah, I will just stop here and then I draw the current carrying conductor here, which is going upwards. That is the current. Then the magnetic field are in concentric circles. Okay, so I took that as well. This is B vector. This is DL. Let me say this is DL, and this is R. This is I. Okay. So consider a current carrying conductor where the magnetic field lines are in concentric circles. Are in concentric circles. Okay, wait, actually, what does it say? Along the conductor. I would say along the conductor. Okay. By using Biot-Savart's law, now that's what I should call it. By using, I had some doubt with that name, that's why. Biot-Savart's law. We are writing it as, okay. Oh my god, bro. Can I just not face this issue? B is equal to mu naught by 4 pi into 2I by R square. Is it R or R square? I'm not sure. It's just R. Okay, just R. I just have some doubts in these formulas for some reason. So mu naught by 4 pi into 2I by R. This is the one main one. I take the the line integral of the dot product of B and dl vector. So B dot dl vector is equal to the line integral of B dl cos theta. Now technically we know that theta is equal to 0 degrees in this case, because the moment we get to check the dl and the B, the angle between them is 0. So that's one thing. So B dl cos theta, it's very small, it's very negligible by the way. So B dl, I try to check this out. So the integral of this will be something like this. So mu naught by 4 pi into 2I by R into the 2 pi R. Okay, and this R, now basically I can cancel this, and 2 will get cancelled with 4. So we get mu naught I, which is basic I is I enclosed. So B's line integral of B dot dl vector, that's the dot product, is equal to mu naught I. This is the derivation of Ampere's circuit law. But technically this looks like I'm actually doing an application of this law. Not gonna lie. Now I have to do the applications of Ampere's circuit law. So this is gonna be similar to what we had learned in Gauss law or Gauss theorem. Like we had some applications where we took an infinitely long charged conductor and then the Gaussian surface around it, so that we can calculate the electric flux through it. And then we also did the same thing where we took it positive charge and then the Gaussian surface to calculate the electric flux again. Same case. So yeah, this is it's similar to that, but you can say. Well, is it dark? Let me increase the brightness. Ooh, yeah. It kind of looks like my brightness is just too down. That's why. I'm gonna keep it like this, but here. I felt like my brightness is just too down low. That's why. Hmm. I application, or we can just write this down once more. No, never mind. Application. I think I am confident enough for that. I'll just remember that. Consider a current carrying conductor such that the current is moving in upwards direction, and the magnetic field lines produced along the conductor is in concentric circles. Then the radius towards the nearest magnetic field would be r, and then you can say, I mean, not much, we don't need to write much about this statement, but for applications of ampere circuit law we need to do that. Consider a current carrying conductor having an inner core with such that the current for that is I dash, okay, and the magnetic field around it be is in circles constant clockwise direction, because by applying this we get to know that. Oh wait, this is kind of wrong, right? Isn't it? Huh? Might be wrong with directions of the magnetic field after check. B outside, B at surface, B inside, the magnetic field outside, magnetic field inside, and that's how we have to check. If I'm checking inside, then it will be A. If I'm checking surface, I will be have to. Okay, wait. There's an area difference, area of cross section difference. If you look at this, that's for certain ideas I got. That this, let's say, is a cylinder, which is actually a fire, magnified portion of a fire. And fun fact, there is another inner core of this, and I take the magnified portion of that, I do this, then take this out. Yeah, then what else do you want? I have to make another one, which is a, okay. A. Then why are we taking B out? Say what? B inside. Here's the case as for R as A. If you're taking it off, I should take it as R, then that's fine. Let's say this is P. This is supposed to be like this, right? So yeah, let's say this is current I. This is I dash. What else do I need to do? Be outside. I'm using ampere circuit law. So that dl, which is mu naught I. Okay, wait. So this is that's what I want to. Okay, ouch. Bad. I swear I'll never buy these pens, bro. I'm not gonna reveal the name, but the problem is that whenever I try their new pens, these break out so easily. Like, oh my god. You can even see that one minute. You can even see some broken parts here. It shouldn't be like this, bro. I can like, bro, whenever I write down the ink part of this part, right, it easily like gets detached from it. It makes it even more difficult. Like, plus it gets stuck like this. So, oh man, it kind of wastes my time whenever I write. And not only that, you can even it's fine. You can fix this thing, but it's just too delicate. Like, I think any person can break this nicely. That's the problem. So the quality of these pens are very poor. Like, I'm not actually like blaming or anything, but they break so easily. That's a problem. And then just detaches so easily. That's the only two problems I've seen in this pen. Overall, the pen works normal. I just want that to be covered. Oh, oh, okay. So something like this, right? I take 2 pi a again. Is that fine, or should I take 2 pi r? Have it out based on that. Okay, no problem. That's great. At least I got some idea that I should have taken 2 pi r. Now that makes it more sensible. Now let me just put this here. So b into 2 pi r is equal to mu naught I dash. Technically it's I dash, not mu naught I dash. So I dash is supposed to be a by small a into y, which means that, no, sorry, I dash is equal to small a by a into y, where the small a is 2, sorry, pi a square by pi r square into y. I hope I'm not wrong, am I? I am wrong. Okay, wait. Oh, okay, okay, my bad. Kinda this. Okay, okay. be it inside. So technically r square is smaller, my bad. And they should have given a different term for that. Why it bothering with it? So let's say this is small a and this is capital A. So technically this shouldn't be like this. So it's like pi r square by a pi a square. The reason why this because r square is smaller than a square. R is a smaller radius in this case, so I dash is equal to I r square by a square. And when I do that, I should get b is equal to mu naught I r square by a square into 2 pi r. So I get it as b is equal to mu naught I r by 2 pi a square. I hope I'm correct. Okay. So this is a pretty much new application of the Ampere's circular law. Very interesting, I like it. But it was a bit confusing at first glance. Like the way like in the notebook it's written as r greater than a outside, r smaller than a inside. Technically I should just take r, but then r here is same. You're just basically taking r as a variable, which is a bit confusing. What is this? Date. Tomorrow is Wednesday. So day after tomorrow, I'm not sure whether you guys heard that notification, but yeah, tomorrow is Wednesday. Day after tomorrow is Thursday. It's 25th, 26th, 27th, 28th is Sunday. Okay. Okay, I don't know whether you guys know this, but in Gulf region or Middle East regions, the holidays are literally, or the weekends are literally on Friday and Saturday, not Saturday and Sunday. So we have to go to school on Sunday. I know it looks pretty weird. Why are you guys going to school on Sunday? But I think it's fine, no problem, right? Like basically Friday is a religious holiday for me. Like I have to go to mosque and pray, and it would be really hectic if I had any schoolwork or anything. So I won't like having school on Friday. That's one thing. I'd like to have only like Friday, Saturday as holidays. It's fine if I don't get holiday on Sunday. It's fine. Not a big problem for me. It's just so not normal for me. So I'm not used to having Sunday as holidays, but okay, that's great. Okay, I'll accept it. And I know that there are only 4 days left. So today, tomorrow is day 72. So that is Wednesday. Day 73 is Thursday. Day 74 is Friday, and day 75, the last day, is on Saturday. So on Sunday, and the next week Sunday, well, not next week Sunday, my bad. This Sunday, technically we would be having. Yeah, I don't remember, but yes, on Sunday we'll be having the normal live streams. What do you guys say? Like, do you want me to a live stream? I'm not sure about that, and nobody's watching as well, so I'm not sure about that event. But yes, if you want, I can do that. It's not a big problem. We can have some small amount of fun and then also study. But it will be a bit hectic as well. But no problem. I will be able to do that. Do that. You just have to remind me or anything. Because usually I don't know why, but I sometimes prefer off streaming studies because I feel like I can get more privacy and more security. Doing live streaming while studying is really great. It makes me locked in so hard. Like that's the thing. But the problem with this is that I just become a bit insecure here. So yeah, like it's like having eyes on me myself, for the whole time. I know it looks like but and then you might be saying like, oh yeah, bro, but you are the reason why you're doing this, right? That's why we are putting eyes on you. But the reason why I would do that is because I want to interact with you people. I want to have some fun, but while like studying, and having eyes on me instead if you don't know, kind of makes me locked in for really bad. Like, I don't know. Trust me, if anyone does a live stream and he's dedicated to do it for 12 hours, then it's possible. I'm not saying that he cannot do it at all. It's possible for every human being if he is dedicated to do it and he doesn't want to give up. That's one thing. Like, I'm not saying that I'm not boasting myself, but I understood from my experience. Like, if you have that dedication, then you can do it. Like, I know that I have done 12 hours streaming, but it doesn't mean that, like, I'm boasting, and I just said it from my experience as far as I know. So yeah. And yeah, so what do we need to say here? Application again. Let me do that again, redo it. So let's say I have a magnified portion of a wire, and this is the area of cross section. Then I have another core of the wire, which is like present inside of it. Let's say that this is the center of this. This is the one, another one. This, let's say, is A. This is small r. This is R, and this one is a bigger version, which is here. Let's say that this is point B. I draw a magnetic field line around it and kind of make the arrows. Now, from the thumb rule, 1 minute, this is I, and this is I dash, you know, just to make this sure. So I do this thumb rule, and then I get to know that this is somehow the direction of magnetic field. Then if I somehow show it to you, this will be R smaller than A, and this is R greater than A. And if I think about it, application of Ampere circuit law, B is equal to mu naught by 4 pi by Biot-Savart's law into 2I by R square. This is the new one I learned. The one which we studied was mu naught by 4 pi into ideal sine 90 by 2, but this is sine theta by R square. Got it. Is it R though? What's the code? R square? Yes, it is. No problem. Okay, so that's one thing, Biot-Savart's law, but to be honest, we should do this in a sequential way. Okay, what is the statement though? Because we need to know that. First we'll do B outside here. The statement will be like, consider a magnified portion or magnified weave of a wire such that current I is passing through it, and there is an inner core of wire and present inside it where the current passing through it would be I dash, and considering the radius of the magnified of the weave of the wire would be A, and the small wire be R lesser than A, and the magnetic field around it is in concentric circles produced along with it. And let's say this is the direction, so I hope so this is gonna be clockwise, anti-clockwise, my bad, anti-clockwise direction. So if you do this right, so yeah, sorry, is it like this? Because if I do it like this is wrong. This is understand. Or am I doing it wrong actually? 1 minute. Technically, if I do this, that's no problem. Yeah, okay. So B outside, which means finding the outside of a magnetic field, that is B is equal to mu naught by 4 pi into no, actually it's not like this. We have to use the Ampere circuit law here. So B dot dl vector is equal to mu naught by mu naught I enclosed but no need. So that is B into this dl is equal to mu naught by I, and that is B into 2 pi small r is equal to mu naught I, where small r is not much greater than A. So mu naught I by 2 pi r. That's the end of the story. So B at surface. So this time we're gonna take it as A because R is equal to A. this time if I take the Ampere circuit law, B dot dl vector is equal to mu naught I, where this is B line integral dl is equal to mu naught I take this as B is equal to mu naught I by 2 pi A. Now B inside is the main important factor, I believe, so making this one out is important. So B inside, it was B this one, line integral of B dot dl vector is equal to mu naught I dash, because this I dash is different, so I dash is technically this small area by larger area into I, because I dash is the current in a smaller inner core wire, so it's smaller area. So doing taking that factor, numerical factor small a by small area by big area, so let's say A dash. So pi, now here in this case B inside, so R is supposed to be lesser than A, so pi R square by pi A square into I is equal to I dash, and this pi is cancelled, so I R square by A square is equal to I dash. Okay, got it. Now, what else do I need to do? I did the line integral. B dl is equal to mu naught into I R square by A square, and this one is supposed to be 2 pi R is equal to mu naught I R square by A square. So B is equal to mu naught I R by 2 pi A square, which is the one I was finding out the whole time. And this is the one which we did and complete. So let's go. Hooray, we did it. So this chapter is overall fine, not that hard, not that easy as well, because the derivations have some good level of equations and you need to understand them nicely. Like I don't know why, but I kind of got confused in Biot-Savart's law, so I have to be really careful with that. And with the directions, I think I'm fine with that. That's not a big problem for me though. So I believe that I practiced it twice, so I'm able to do it nicely. Uh, I hope I'm capable of this thing now. If I want, I can go through it once. But right now, I feel like I have to start off another subject. Let's do maths, then we'll move on to chemistry, then bio. What do you guys say? Let's do bio at last. But yeah, bio has a heavy work to do. Oh god, this is not gonna be an easy one, huh? We have to complete evolution. How many periods of bio do we have this tomorrow? 1 minute, let me think. Tomorrow is Wednesday. At first period we have bio, so we'll be doing some bio practical. Second, English. Third, physics. Fourth, physics. Fifth is chemistry, I believe. Sixth, I'm not sure. I don't know whether we have bio 2 periods tomorrow. To check. Oh, okay. As I was saying, still a bit confused about this one. Yeah, so I'll do maths now. I think I've done this. I'll just go through this once. mu naught by 4 pi into ideal sine theta sine 90 by r squared. But that's ideal by r squared, to be honest. Just have a small doubt with Biot-Savart's law. That's the only thing I have to go through. Then, what else? I think I'm not that much stuck with this thing. Yeah. Yeah, then this derivation, b is equal to mu naught by 4 pi into 2I by r. A bit confused with this one. This is the Biot-Savart's law that we have to learn. Because I was absent on that day, so I have to go through that myself. And basically, yesterday, I was absent yesterday. In short, that's what I'm saying. That should look good. So mu naught by 4 pi into 2I by r. Then b dl, b of a line integral dl is equal to mu naught I. L dl, it's 2 pi r. Mu naught I. Oh wait, then I should do this and then I get mu naught I. I got the idea of this one. Just going to the derivation, mu 4 pi, mu naught by 4 pi into 2I by r. You take that and then dl 2 pi r, no, dl 2 pi r. Then you get this, okay. That's it. Yes, okay. We completed physics, now it's maths. You know, sometimes I have to go through the derivation so that I don't forget them. To keep the flow going through. Now we'll do chemistry. Sorry, maths. I'll just take the textbook, to be honest. Why should I take the notebook? I think I can try it by myself. If you don't know, in maths we have started the unit of calculus, and we are doing great with that. The calculus that we are doing is basically differential calculus, so we are doing continuity and differentiability. It's a good chapter. I like this chapter. It's easy. It's not that hard, to be honest. But it's a bit lengthy. To be honest, it's a bit lengthy. Not that lengthy, but it is. So you have to be a bit aware of this chapter as well. It takes time to complete, but yeah, this chapter is not that difficult. I expected, like to be like these chapters will be to be really tough. But I think I will get to know that soon enough. I'm a bit scared of application of derivatives for some reason. Like these look so crazy. I'm not sure about application of derivatives, how those questions will be. Like these are a bit too. Um, I don't know how to explain. I think we are gonna do it. No problem. We are gonna do this. Then application of derivatives. After that, we have this one chapter, integration or integrals. That chapter is supposed to be the hardest chapter in 12th mathematics, but they basically call it as the lengthiest chapter because there are 7 exercises, and each exercise has a lot of amount of questions. Like I do agree that continuity and differentiability also has good amount of questions, but not much. Like you still can do it normally. So that's one thing. So yeah. Like overall, I feel like 12th maths is not that hard to be expected, but there are some chapters which are a bit challenging. Bit challenging. Not like I'm not saying that they are really challenging. Bit challenging. Like let's say in inverse trigonometric functions. Like I have a doubt in substituting some varies like some functions when with x, or let's say any kind of variable, when you're trying to prove something or finding or evaluate something. That's the only part of which makes me confused. So yeah, that's the only thing. But rest all, I feel like yeah, we can do this in inverse trigonometric functions. I do have an idea of the of formulas because I've gone through the 11th formulas like 3 to 4 times, like in 11th standard. So I have a good catch of them. But yes, if I do forget anything, then I think it would be much better for me to remember that. Like that's one thing about it. Ouch, kind of hurts, but it's repairing. Hey, okay. So I'm gonna do. I think I have to do all the how many questions? Or what today? How many questions I have to do? I think I did. To be honest, I did these 2 questions today itself. So I'm gonna start off with only 2 questions. So maths is gonna end fast. Then we can move on to chemistry fast enough. That's great. So cos x dot cos 2x dot cos 3x. This is the function. 1 minute. I'll go to the toilet. Come back. Then we'll start off. Then we'll do no. Actually, I have to do 3 questions because I had done this thing too, right? So yeah. It's basically 3 questions. finally came in. Oh, 2 weeks, man. Nice. I appreciate that. I don't know who was that person, but hey, thank you very much, man. Okay, so let's start off. So I have to only do 3 questions today, which is great. So let's say that I have a function which is let cos x, cos 2x, cos 3x, they are multiplied. So in these types of functions, I have to apply my full knowledge of differentiation that I've learned overall. Not continuity though, because continuity is a bit different topic here. But talking about the function, let's say that y is equal to this function. So y is equal to cos x, cos 2x, cos 3x. And here, in these types of complexes, we may take log, because log makes it more simplified. So I like it. That's what we had done this in chemistry and physics. We just usually use it for, I don't think so we use log values in physics unless and until if there is any complex calculation, but yeah. So we take log y is equal to log of cos x plus log of cos 2x plus log of cos 3x. So log y is equal to log of cos x, right? So wait, I have to differentiate now. So differentiating the function with respect to x, w or tx. Okay. So d log y by dx. Actually, you know what? We can write this fast enough, but I'm not gonna do that. So just I'm wasting my time with this step, but no problem. This is an unnecessary one, but I'll still do it. Cos 2x plus cos 3 log cos 3x. Okay. Then I write here the dx. Then I write here 1 by y dy by dx, because the differentiating log x, d log x by dx is equal to 1 by x. So that's one thing I get from here. So 1 by y into dy by dx. Now change will apply because y is a function basically. And then this is I'm taking the log and then I'm taking differentiation here. So this will be 1 by cos x. Then this will be 2 by cos 2x plus 3 by cos 3x. And yes, we did it. So dy by dx is equal to y. Am I doing something wrong? I hope so not. 1 by cos x plus 2 by cos x, cos 2x, my bad, plus 3 by cos 3x. So in this one, y is multiplied to this function. So dy by dx, okay, where do we go? Cos x, cos 2x, cos 3x, 1 by cos x plus 2 by cos 2x plus 3 by cos 3x. And yeah, that's it, bro. We did it. Do we get it? Yeah, we got the value function. Then I'll start with third, then we'll do the second one. Second one looks a bit more complex, but to be honest, it is not that complex at the same time. The question looks like complex. That's the beauty of mathematics. Like, you have something which is looking very complex, but at the same time it isn't. That's the that's the beauty of it. So log x raised to cos x. How are we gonna do this? Technically, we can take log again and then make it much easier for our lives, but we'll still do it. Let y is equal to log x raised to cos x, and differentiating the function with respect to x. Actually, wait, taking log on both sides first. That's what I'm going to do. It will make it much easier. Taking log on both sides, log y is equal to log x cos x. log of y is equal to cos x log of log x. Okay, now gotta apply the chain rule carefully here when I take the differentiation. Differentiating the function with respect to x. Hey, the function with respect to x. D log y by dx is equal to d of cos x dot log of log x. Here it's dx. This is gonna be 1 by y dot dy by dx is equal to, now this is minus sine x. Okay. Is this supposed to be a quotient rule? Technically it is, right? Yeah. 1 minute. So u dash v, so log x plus, did we do this question actually? I'm a bit confused, but okay, never mind. Cos x plus cos x dot the chain rule log of log x, 1 by log x dot 1 by x. Dot 1 by x. So it's like 1 by y dot dy by dx, I hope I'm not wrong here, minus sine x dot log of log x plus cos x dot x by x log x, 1 by y dot dy by dx, this is the one, is equal to minus, so this is x log x. To be honest, we can just take it as cos x minus x log x sin x dot log x. Oh my god, what is this function here? Differentiated function is crazy. It's even more crazier than this. Oh my god. Dy by dx is equal to y. You know what, I'm gonna change the value, so it's log x raised to cos x, and then multiply to this will be cos x minus x log x sin x log of log x. Oh my god. I'll take a square bracket, you know what? Yeah. I don't know whether this is correct, but let me check. This. Okay, so we did get it correct, but what you can do here is instead of we don't need to take the LCM. That's what it says. Okay, then that's much greater. Second question. This is not supposed to be that hard, to be honest. I did this question once. X minus 1 into x minus 2. Then why am I doing this again? Because for practice, bro. Practice makes you better. I won't say it's perfect. I don't say practice makes you perfect, because and a person cannot be ideal. He can be close to an ideal person. That's what I say. So yeah, I'll just say practice makes you better, because you actually develop day by day if you practice much more. So that's one thing. X minus 1 into x minus 2. Root of that, basically x minus 3. Should have taken the whole raised to half instead of root. I swear, bro, this pen. X minus 4 into x minus 5 by taking log on both sides. Yeah, it's kind of weird to take log here, but it's fine. On both sides. You know what I thought of? If I'm taking the log, I should also take the anti-log, but technically we are using an equation, and taking log on both sides won't affect it. Eventually you'll get the same value. That's the thing. So Shouldn't be giving you different values. Log y is equal to log of x. Actually, I can take this as a square bracket, I guess. X minus 1, x minus 2 by x minus 3, x minus 4, x minus 5. Then take the whole half of this, raised to whole half. So log y is equal to 1 by 2 into this square bracket into log of x minus 1 plus log of x minus 2 minus log of x minus 3 minus log of x minus 4 minus log of x raised x minus 4. So that's a square bracket here as well. So log y, okay, now differentiating the function with respect to x, differentiating the function with respect to x, the function with respect to x. Okay, we have enough time. We can also complete this and then we can start off chemistry. But I feel like we can do an extra question here just for practice. Okay, because we have an exponential function. We need to deal with that as well, right? So we can do that. 1 minute. Okay. Okay, what I was doing here was log d of log y. Let's not write that. 1 by y dot dy by dx. I'm being a bit direct here. D of y by dx is equal to half into. Now, I take this differentiation. I get 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. Damn, it's a big number. Now, not yet. We have to take and transpose y here. So 1 by 2 into y. So I'm gonna not write down y because I don't want to waste and I don't want to put an unnecessary step. So x minus 1 into x minus 2 by x minus 3 into x minus 4 into x minus 5. That is basically your 1 by x minus 1 plus 1 by x minus 2 plus 1 by x minus 3 plus 1 by x, sorry, minus here, minus 1 by x minus 4 minus 1 by x minus 5, and that's the value here. We did it, guys. I'll do fourth question just for, no wait, we did fifth question as well. Okay. Oh man, I have to do fourth. Okay then, no problem. X raised to x minus 2 raised to sine x. Okay, how do we do this? I don't think so we need to divide them. I can just take log and then subtract, it's fine. So let y is equal to x raised to x minus 2 raised to sine x. It is very weird to have those exponents and a variable or exponent. It really makes me a bit feel more weird. Whenever we have this type of variable exponent, it makes me feel really weird. That's one thing. Ouch. Bit too painful in evidence. I don't know, man. I'll keep it down. Uh, yeah, I don't remember much of it. Let me think. Yep, okay then. Doing this, log y is equal to log of x raised to x minus 2 raised to sine x. Now log y is equal to taking log. I'm right now taking log on both sides. Log on both sides. X log x minus Sinex log 2 logbook. Oh wait, Sinex log 2. I do know this. Log 2 is 0.3 010, right? Yeah. But 0.3 is actually the answer. But if you want the exact value, it's gonna be 0.3010. But I'm not gonna write that whole thing, and yeah, I'm not gonna waste it like that. So, Aro, हाँ यहाँ छो हाँ
नीचे जाओ आता मारी बुला ली
Aro.
जाओ
1 minute. Sorry guys, I'm back. Here I am. I had some work assigned, so I had to go outside. Okay, it's almost 2 hours now. Man, to be honest, I was actually like, no, I was gonna start my stream on 3:20. I didn't know that I was streaming. I was like, feeling like, yeah, I'm streaming normally and it's going on nicely. I just didn't notice. Like, I should have noticed the time and all, bro. Oh, that wasn't good at all. Like, I didn't click the go live button, and the phone showed that it was gonna be starting off soon, and I didn't notice that. That's my mistake, man. Okay, so we are gonna pray Isha now, cause it's gonna get late now. That's why I'm gonna pray Isha, and if you do that, that's much better, right? So we'll do that. Yeah, but I have to do wudu. So let me just do this question, and then we'll go. Bye bye. dy by dx by x minus cos x 1/2. क्या ये क्या ये What is this? Sir, sir. Hmm. ये बात है खाओ एक बार दोनों भी खाना मैं रुको रुकना मैं बोल रहा हूँ मैं सीधा खाए भी नहीं कैसा अच्छा लगता है I don't know what exactly this is. It's like a donut or something, but it's a bit hotter and it does taste very well. So I don't know. I don't know what is this. It says chocolate pie. maths is gonna get completed, I'll start chemistry. Just last question. To be honest, this chapter is good. It's easy. You can do this. It's not that hard. I don't know how hard it is in J, but bro, this is not that hard. I thought it will be really hard. It will be challenging and difficult, but not that hard. But I don't know why, but I feel like application of derivatives will be a tough one. Like there are so many word problems, and I'm a bit of scared of the word problems, bro. So yeah. Like I've seen so many of these types of applications, and those are really crazy level. So I'm a bit scared about that one. But I think we can do it. It's not that tough, right? Like I've never seen anyone mentioning that application of derivatives was that hard. I remember they said like, yeah, calculus is challenging, but you can do it. It's just a bit lengthy. That's it. And they were like, among all the chapters, integrals is easy. Sorry, hard, but the applications of it is fine. It's easy. It's not a big problem. And they never mentioned about derivatives being that hard as well. They also told me that linear programming, then intro to 3D and probability, these three chapters, these aren't that hard as well, so not that tough. Okay, so we completed this, and to this we come to an end of maths. I'll just come in with guys. I will just show this. But try actually. 1 minute. Huh? That was so random. Okay, wait. Number of one question. So 3, 6, 9. Okay, this looks not that bad, right? We can do this. Oh my god, what is this? Okay, so if you don't know what I'm doing, I will just show it to you. Can I show that? Yeah, 1 minute. I think you guys can't see it right now. 1 minute. Can you? Mm-mm. Wait, how am I gonna then? Can you guys see now? Anything? No, what? I think I cannot show teams for some reason. But that shouldn't be the problem, right? What? Okay, wait, not this. This one. And... Oh, I didn't mean general. Oh, what? Okay, I was just looking at the holiday homework of chemistry. Like, there are many, many tables there. Oh my god. That's a lot. Okay, this doesn't look that bad. You just need some good idea of the project tables that you have. That's good. Doesn't look that bad, isn't it? Yeah. I hope this is my project because I don't want to mess up or anything. Sorry. Uh, how am I gonna do this? Wait. Okay, let me just take this off and come back. But I'm sure that you guys cannot see anything, but I just don't know what exactly my project is. But like, oh, well, what? I switched it off. But anyways, never mind. Yes, as I was saying, it wasn't supposed to be showing any widescreen. It should have shown that PDF, but I don't know what's going on. So what? Okay. Okay, let me just Sue. Oh, Ronaldo Sui. Oh, okay, okay. Oh yeah. The matches between Portugal and Uzbekistan. I remember. I don't know what's the status. I don't know who's gonna cook this time. Last time I don't watch football a lot, like, but I do know that. But I do check the statistics and match finals, like what happened at the end result, because that's a time saving. It doesn't take your time a lot. But I don't watch football, to be honest. I would only watch FIFA events and all. That's it. I don't watch World Cup, the PL, the Premier League or anything like that. But yes, if I mention about it, uh, FIFA, I feel like last time they got like, yeah, it was between DR Congo and Portugal, and they got same, and it was a draw match, I guess. Like, both of them scored the same amount of goals, but I don't know how much. I don't think so. It's like 1-1 maybe 1-1. Anyways, though. Okay, never mind. So now it's chemistry. We'll lock in for chemistry, and then we'll move on to biology. Now, chemistry, I think it's a bit smaller too, but biology is not going to be small enough. That's for sure. I know it's going to take some time.
Can't have it.
1 minute, guys. Let me change the place. Biceps kind of hurt though, to be honest. I did some dumbbell work. That's why. 1 minute. I'll mute the mic. Hey there, Weaver. How are you doing? I hope you're doing nice. If you're a new Weaver watching me, then nice to meet you. And I would say, that, you have a great day and all, Please don't be demotivated. Please don't be, defeated. I know you can do this. No matter what stage you're in, you can do this, bro. Or sis. You are the alpha. You are in your prime. You can do it. I know these words look very weird to you, but to be honest, I feel like everyone can relate to these words, and that's why I'm using those. And if it is an old viewer watching me, then I would say hi there. Um, you know, you might be thinking that where was I? Why didn't I stream for so long? It's because I had some feelings. I wanted to actually do some off streaming studies for a period of time, and I did do that. As you can see, it is day 71 of 75 Ultra Hard Challenge, and Alright, hi guys. I'm extremely sorry for making you wait here. I see if you were watching me, and I'm extremely sorry for that. Um, what else can I say? Yeah. So if you're an old viewer, I would say I would appreciate you, man. You have been following me since like almost like 5 to 6 months, I believe. I mean, I feel like my channel is at least 7 to 8 months old, I believe, and yeah, 1 minute. Let me just check my channel's age so that I get some ideas. Now, see, it's on October. It's on October, so if I go to my channel and then I go back, it's 9 months. My bad, 9 months. Okay, so 9 months old. Okay, interesting. Yeah, as I was saying, we will do chemistry work now. Let me go a bit forward. I don't want to be encountering any unusual reptiles or insects. Here we go. Okay. So in chemistry, you need to learn the reaction, disproportionation reaction. Okay, so I think we'll start off with magnetic moment. Okay, a person has finally left. It's fine, no problem. No such problem, bro. I appreciate you. Like literally, he stayed for like 5 to 10 minutes. That's crazy, really crazy, bro. I appreciate you. I don't know he's there or not. He's not there now. My bad. Okay, so let's say that now I'm doing chemistry. Okay, and chemistry will take some time, but I think it's still worth it. Okay, so magnetic moment is mu is equal to n into root of n into n plus 2. And to be honest, if we talk about Mn and Mn2 plus, we know that Mn is Mn's atomic number Z is equal to 25, so its electronic configuration will be argon, 4s2 3d5. So I'm gonna write that down here. Then what else? What else? Ouch. Yeah, my bad. It hurts. Yep. Okay, no. EC electronic configuration, but if I talk about Mn2 plus, then its atomic number will be the same, but it will lose 2 electrons. So the electronic configuration will be argon 3d5. 2 electrons are lost in the s orbital. So this is supposed to be having 5 unpaired electrons. So n is equal to 5. So mu is equal to root of 5 into 5 plus 2. 5 into 7 is equal to root 35. Bohr magneton, BM. Mu is equal to root 35 Bohr magneton. Nice, we got to know that unit. Okay, that was a bit weird. One minute. I don't know why does that say that tick mark. I'm sorry. Okay. Oh, we can do that. Alright, okay. Should have mentioned chemistry, yeah. Okay. Now for cobalt is there, and cobalt 3 plus. Now, if you talk about this, in 3D, cobalt comes in 3D series. So scandium, titanium, vanadium. Sorry, not titanium. Is it titanium? Yeah, titanium, vanadium, chromium, manganese, iron, and cobalt. So cobalt is atomic number is 27. Z is equal to 27. Then its electronic configuration will be argon again, with 4s2 3d7. Now if I say that about cobalt 3 plus a cation, it's again atomic number is same, but the electronic configuration will be argon 3d6. Talking about this, its d orbital has 4 unpaired electrons. Fun fact: root 35 Bohr magneton will be 5.92 Bohr magnetons. So that's one idea we can get from here. This one, however, the d orbital will have 4 unpaired electrons. So we will say n is equal to 4, and then calculating its magnetic moment, 4 into 6 is equal to root 24, which is basically 4.899 something. I calculated it from log earlier, so it's I remember Bohr magneton. So yeah. Now here are some theoretical questions. Technically this chapter is not numerical based, so it's not a physical chemistry chapter, it's an inorganic chapter. Talking about D and F block elements, so we need to have some great idea about it. Why do transitional metals form alloys? Now, transitional metals have similar in size of the atoms of the transition metals are similar in size, and we know that alloys are homogeneous mixtures of two or more metals. So when mixed, they are not altering the structure of the metal, and thus, yeah, they can easily form alloys. And yes, due to the similar size, because of the lanthanoid contraction, that's one such reason. And then we got water interstitial compounds. Now this is another one. Interstitial compounds. Let's say that transition metals have voids in their surfaces where it is capable of absorbing small atoms like carbon, nitrogen, and boron, which are the pre-Bullock elements, if you don't know. And these elements, when absorbed in it, will form the interstitial complex or the compounds. Not complex, let's not say complex, interstitial compounds. Now these interstitial compounds can retain metallic conductivity, then have high melting and boiling point. Then what else? They are harder than the metals itself. Then what else? I think that's it, right? I mean, is there anything else? Yeah, wait. Chemically inert, that's one thing too. Chemically inert. And then non-stoichiometric. And there are. Okay, that's one such idea we got. What else is there? Neither ionic nor covalent bonds are formed in this. Yeah. Why do transition metals form complexes? Now they form complexes due to small size. Okay, this one is a bit new for me, so I'll have to go through this one. Then why is E not value for Mn3 plus to Mn2 plus? This one is a bit confusing question, so I'll go through that as well. Then disproportionation reactions. When same species of the when a same chemical species undergoes oxidation and reduction in a reaction. Oh, when okay, wait. When same species in a chemical reaction undergoes reduction and oxidation, then that reaction is called as disproportionation reaction. We need to remember the example, so I have to learn that. I will learn that example now. Mn has the highest number of oxidation states, variable number of oxidation states. Then we have to learn about oxides, oxocations, and oxoanions, then potassium dichromate. I don't know why, but I have a feeling like go through this question first, then start from this and this potassium dichromate, then move on to the theoretical part. Like that's what I feel. This chapter is interesting. It's good, but it's also a bit confusing when you study this. So yeah. Okay, now let's actually like answer this.
Why lava?
Uh,
Mom बैठा है नहीं है हाँ.
क्या देखे नहीं
Mom बैठा है.
है
इसका कौन है? आता.
पकड़ा पकड़ा थोड़ी देर में खाता हूँ मैं रुको ये थोड़ा ये स्लोगन लिख रहा ना
Bisa kan mampu.
तो मित्री को oh yeah actually wait a minute I want to search something
नहीं करी.
खा के लाली रुकी
मैंने खा के वो सभी चुटनी सुना. Monday. स्कूल का मालूम नहीं.
हाँ
हाँ ले.
रुको थोड़ा गर्म है जी 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 1 minute, guys. I'll eat and come back.
you.